To understand why the United States once seriously considered detonating a nuclear warhead on the lunar surface, one must first strip away the modern nostalgia for the space race. We remember it today as a romantic era of silver suits, giant leaps for mankind, and the noble pursuit of scientific discovery. But in the late 1950s, space wasn't a place of wonder. It was a cold, dark, and terrifying extension of the battlefield. The stratosphere was no longer a ceiling, it was a highway for potential annihilation. Every rocket launch tracked on flickering radar screens was a message written in fire across the sky. Every satellite was a potential eye in the heavens, and every orbit was a declaration of supreme technological and military power. The celestial bodies weren't destinations for explorers, they were high-ground positions in a global game of King of the Hill. On October 4, 1957, the world changed forever. The Soviet Union launched Sputnik 1. It was a small, polished metal sphere with 4 long antennas, but its impact was heavier than any bomb. As it beeped its way across the American night sky, the shock wasn't scientific, it was psychological. For the first time in its history, the United States felt physically vulnerable. The vast oceans that had protected the American mainland for centuries suddenly meant nothing. The American public looked up at the stars and didn't see the infinite, they saw a Soviet victory. They feared something far worse than losing international prestige. They feared that the United States had lost its grip on the future. They feared that the high ground was now occupied by a communist regime that had beaten them to the punch. The fear was a cold, gnawing weight in the pit of the national stomach, and the government knew that a conventional response wouldn't be enough to cure it. The launch of Sputnik proved a singular, terrifying fact that kept American generals awake in the small hours of the morning. If the USSR possessed the rocket technology to put a harmless 184-pound metal ball into orbit, it possessed the technology to put a multi-megaton nuclear warhead there as well. The sky was no longer a safe canopy, it was a firing range. The military reality of the late 50s was a nightmare of gaps, the bomber gap, the missile gap, and now the space gap. To the Pentagon, space was the ultimate high ground. From orbit, a nation could rain down destruction on any city on Earth in a matter of minutes, bypassing every radar net and every interceptor squadron currently in existence. American generals and strategists began asking questions that felt like they belonged in the pages of a pulp science fiction novel. How do you demonstrate dominance in an environment where there are no borders? How do you prove your nuclear capability to a rival without actually starting a world-ending war on the surface? How do you provide a visual demonstration of force that is so massive, so undeniable, and so terrifying that it forces the enemy to pause? The traditional methods of showing strength, naval exercises, troop movements, or atmospheric tests on remote Pacific atolls were starting to feel small. They needed something bigger, something cosmic. It was in this atmosphere of escalating paranoia and one-upsmanship that a group of scientists and military planners at the Air Force Special Weapons Center in New Mexico suggested an answer. It was a plan so extreme, so brazenly aggressive, that it almost sounds like a piece of dark satire from a Cold War thriller. The proposal was simple: explode a nuclear weapon on the moon. The plan was given a dry bureaucratic designation, Project A119. Its formal title was a study of lunar research flights, but behind the sterile language of physics and orbital mechanics lay a plan for a cosmic warning shot. The goal was as straightforward as it was horrifying. The Air Force wanted to deliver a nuclear device on the lunar terminator, the line between the dark and light sides of the moon. If timed correctly, the explosion would create a massive, luminous cloud of dust and radioactive debris that would be illuminated by the sun. This wouldn't be a hidden test in a desert. It would be a spectacle. It was designed to be a massive flash visible from Earth with the naked eye. The logic of Project A119 was built on the cold calculus of perception management. No casualties. Unlike a strike on a city, the moon was a vacuum. There was no life to extinguish, no cities to burn. No immediate retaliation. It wasn't an act of war against the Soviet Union, it was an act of research on a celestial body. The ultimate message. It was a signal to the Kremlin that said, we can reach anywhere, we can touch the heavens, and if we can hit the moon, we can hit you. The planners believed that a lunar mushroom cloud would restore American confidence and shatter Soviet morale. It was to be the ultimate PR stunt, a billboard for American nuclear might that would hang in the night sky for every human on Earth to see. They wanted to turn the moon into a screen upon which they would project the power of the United States Air Force. In the minds of the planners, the moon wasn't a sanctuary, it was a target, and they were already beginning to calculate the weight of the warhead and the trajectory of the rocket that would deliver the most expensive and the most dangerous fireworks display in human history. To ensure the project didn't look like a purely mindless military stunt, the Air Force recruited some of the most brilliant scientific minds of the era to provide a veneer of research. This was, after all, a study of lunar research flights. Among the young scientists brought into the fold was a brilliant planetary astronomer named Carl Sagan. Decades before he would become the world's most famous advocate for the beauty and fragility of the cosmos, a young Sagan was tasked with a grim mathematical problem. He had to calculate the expansion of the dust cloud in the lunar vacuum. The scientists were asked to find the scientific benefits of a nuclear detonation on the moon. They proposed several theories. Seismic data. The blast would send shock waves through the moon's interior, allowing sensors, if they could be landed, to determine what the lunar crust was actually made of. Chemical analysis. The explosion would vaporize the lunar surface, and the resulting light spectrum could be analyzed from Earth to identify minerals. The search for water. Some argued that the heat might release trapped gases or ice from beneath the surface, but these were justifications, not motivations. The true science being practiced was the science of psychological warfare. The researchers were essentially being asked to calculate how to make the most impressive explosion possible. They studied the visibility of the flash, the duration of the dust plume, and the exact yield of the warhead required to ensure that someone standing in a village in Siberia or a suburb in Ohio could look up and see a bright artificial star blooming on the face of the moon. The architects of Project A119 understood that for a warning shot to be effective, it couldn't just be powerful, it had to be beautiful in a terrifying primal way. This wasn't about military efficiency or tactical destruction, it was about the intersection of advanced physics and grand theater. The scientists at the Armor Research Foundation, under the direction of physicist Leonard Rifle, began to treat the lunar surface as a canvas. To ensure the world would see America's nuclear signature, the team spent thousands of hours studying the unique environment of the lunar vacuum. On Earth, a nuclear explosion is a familiar, albeit horrific shape, the mushroom cloud. But on the moon, there is no atmosphere to provide resistance, no air to be heated into a rising pillar of fire. The physicists analyzed lunar dust behavior. They calculated how the fine abrasive regolith of the moon would react to a multi-kiloton blast. Without air, the dust wouldn't settle. It would be kicked up in a perfect expanding sphere, traveling at ballistic speeds. Blast visibility. To maximize the spectacle, the detonation was planned for the terminator, the razor-sharp line where lunar day meets lunar night. If the bomb exploded just inside the dark side, the sun's rays would catch the rising plume of dust against the black backdrop of space. Radiation dispersal. They needed the cloud to be bright enough to be seen by a farmer in Kansas and a factory worker in Vladivostok. They theorized that the solar wind would illuminate the ionized gases, creating a shimmering, ghostly glow that would linger for hours. It was psychological warfare on a planetary scale. The message was designed to be subconscious. The moon, that ancient symbol of the night, now belonged to the United States Air Force. By lighting a match on the face of the moon, America would prove that it had the reach of a god and the temper of a titan. It was a demonstration of capability intended to bypass the intellect and strike directly at the heart of Soviet resolve. Despite the massive funding and the patriotic fervor of the late 50s, a shadow of unease began to spread through the research labs. As the mathematical models became more precise, the consequences of the project became more haunting. Some of the very scientists hired to make the moon bomb a reality began to realize they were designing a tragedy. The warning started as whispers in classified memos, but soon grew into a chorus of dissent. Radioactive contamination. Biologists and astronomers warned that a nuclear blast would irrevocably salt the lunar surface. If the moon held any secrets about the origin of life or the history of the solar system, they would be buried under a layer of terrestrial radiation. We would be ruining the greatest laboratory in existence before we even set foot in it. Unpredictable debris. While the vacuum allowed for a great show, it also meant that debris could potentially enter unpredictable orbits. Some feared that moon shrapnel could fall back into Earth's atmosphere or, ironically, damage the very satellites America was trying to protect. The future of exploration. A small faction within the project, including a young and idealistic Carl Sagan, began to argue that the moon should be a destination for discovery, not a proving ground for destruction. They feared that nuking the moon would set a precedent that space was merely a garbage dump for humanity's worst impulses. But beyond the scientific concerns, there was a visceral, pragmatic fear that gripped the military planners: the launch failure. The launches of the late 1950s, the Vanguards and the early Atlases, were notorious for spectacular, fiery explosions on the launch pad. The space race was currently a graveyard of twisted metal. The planners had to confront a horrifying scenario. What if a rocket carrying a live nuclear warhead suffered a guidance failure during its ascent? A nuclear missile exploding over Florida or drifting into a random orbit around Earth wouldn't impress the Soviets. It would terrify the world and turn the United States into a global pariah. The warning shot could easily become an accidental declaration of war against the entire planet. As the project moved toward its final stages, a deeper, more philosophical anxiety began to settle over the Pentagon. It was the realization that in the Cold War, every action invited an equal and opposite reaction. If America nuked the moon to prove a point, the Kremlin would be forced by its own ideology to do something even more extreme. The strategists realized they were standing on a threshold. The nuclear escalation. If the moon became a legitimate target for demonstrations, what would stop the Soviets from detonating a 10-megaton bomb on the lunar surface? What would stop them from claiming the craters for their own tests? A radioactive proving ground. Space, the final frontier, could quickly be transformed into a lawless wasteland. Instead of a place of peace and shared human achievement, it would become a high-altitude firing range, cluttered with the radioactive husks of prestige experiments. The irreversible precedent. The moon had been a constant in human history for millennia. It was the clock, the calendar, and the muse for every civilization that had ever existed. To scar it for the sake of a temporary political advantage felt like an act of cosmic vandalism that could never be undone. There are some lines in history that once crossed, changed the nature of the human species. Project A119 represented a choice between space as a battlefield and space as a sanctuary. As the documents were eventually shelved and the project was quietly canceled in 1959, the United States made a silent, perhaps unconscious decision. They decided that the moon was worth more as a dream than as a target. The cancellation of A119 paved the way for the 1967 Outer Space Treaty, which legally barred the placement of weapons of mass destruction in orbit or on celestial bodies. The moon bomb died so that the moon landing could live. It remains a chilling reminder of a time when the world was so close to the edge that even the stars weren't safe from our shadows. Project A119 did not end with a dramatic standoff or a public outcry. There was no congressional hearing, no whistleblower on the evening news, and no official decree from the Oval Office. Instead, the project simply withered away in the dark, dying in the suffocating silence of bureaucratic neglect. By late 1959, the folders containing the calculations for lunar mushroom clouds were stamped with new classification codes and moved to the back of the steel filing cabinets at the Air Force Special Weapons Center. The project wasn't shelved because it was impossible. On the contrary, the physics were sound and the rockets were rapidly improving. It was shelved because it was becoming increasingly, glaringly unnecessary. As the 1960s approached, a new philosophy began to root in Washington. Brute force was starting to look like a primitive tool for a modern age. Better, more sophisticated options were emerging from the newly formed NASA. Manned missions. Planners realized sending a human being to the moon and bringing them back alive was far greater display of technological mastery than merely blowing a hole in the crust. A pilot required life support, navigation, and precision, things a dumb warhead did not. Peaceful exploration. The space race was beginning to be seen as a competition for the hearts and minds of the unaligned world. In the court of global public opinion, a nation that explored for the sake of humanity was far more attractive than a nation that vandalized the heavens for the sake of a threat. Symbolic achievements without fallout. The risks of radioactive contamination, both on the moon and in the event of a launch failure, were deemed too high for the meager psychological reward. The moon didn't need to burn to prove American power. It needed to be reached. The warning shot was replaced by the Great Leap, a pivot that moved the United States from a posture of cosmic aggression to one of cosmic ambition. 10 years after Project A119 was buried, the world watched a different kind of light on the lunar surface. On July 20, 1969, the spectacle the Air Force had craved finally arrived, but it looked nothing like the fire they had imagined. Instead of a blinding nuclear flash, it was the grainy, flickering image of a human being in a white suit, stepping onto the dust of the Sea of Tranquility. When Neil Armstrong and Buzz Aldrin stood on the moon, they delivered a message far more devastating to Soviet prestige than any explosion could have achieved. They didn't destroy the moon. They treated it with the reverence of a sanctuary. They collected samples, set up scientific experiments, and moved with a careful, almost balletic grace in the low gravity. They stood on it. The presence of a human being provided a scale that a bomb could not. It transformed the moon from a distant target to a destination, a place that humans could inhabit. They spoke to the world. When they planted the American flag, it wasn't a claim of ownership through destruction. It was a marker of a journey. The plaque they left behind read, "We came in peace for all mankind." This was dominance without devastation. By choosing the difficult path of exploration over the easy path of demolition, America rewrote the narrative of the space race. They proved that the ultimate display of power isn't the ability to kill a world, but the ability to visit one. Project A119 remains one of the most chilling what-ifs of the 20th century. It serves as a stark, unvarnished window into the Cold War mindset, a period of history where fear was the primary engine of innovation. Looking back, it is easy to dismiss the plan as madness, but at the time it was driven by a cold, desperate logic. In the late 1950s, the strategic question was never, should we do this? It was always, what happens if they do it first? This was the era of mutual assured destruction, where every move was a countermove, and every innovation was a response to a perceived threat. The moon was simply the newest theater in a war that had already consumed the Earth. If the Soviets were going to use the moon as a base or a symbol, the logic dictated that the United States had to get there first by any means necessary. For a brief, flickering moment in history, the moon almost paid the price for humanity's inability to trust itself. It came within a few years of being scarred by the same fire that leveled Hiroshima and Nagasaki. Today, as we look up at that pale, cratered disk in the night sky, we are looking at a survivor. The moon remains pristine not because we lacked the power to harm it, but because we eventually found the wisdom to protect it. Project A119 stands as a reminder that the greatest triumphs of the space race weren't the rockets we launched, but the bombs we chose to leave behind on the ground. It is a testament to a time when we stepped back from the brink of cosmic war and decided that the stars were meant for something better than a battlefield.